form matrices. A matrix is said to be in row echelon form if we have three conditions, and the three conditions are satisfied. The first one is the first non-zero entry in each non-zero row is 1. So the first non-zero one is 1, must be 1, unless the row is entirely 0. Second condition is if row K does not consist entirely of 0, then the number of leading 0 entries in row K plus 1 is strictly greater than the number of leading 0 entries in row K. What does that mean? That means that, okay, here I have an example. Row K plus 1 must have more leading 0 than row K plus 1 must have more leading zeros than row K. Yeah. And the last one is if there are rows whose entries are on 0, they must be at the end. Okay, they are below all the rows having non-zero entries. Okay, 0 entry rows, they are at the end. Example. Here I have one example of row echelon form and 3 examples of non-example of row echelon form. So the first example is 1, 2, 3, 0, 1, 4, 1, 0, 0, 1. So the first condition, leading 1, yes, leading 1. Leading 1. Second condition, row K plus 1 has more leading 0 than row K. So you have 2 leading 0 and 1 leading 0, right? The last one is if they are entirely 0, the row contain all 0, they must be at the beginning, at the end. For example, do I have 1? No, I don't. Suppose we have 1, 0 here, they are at the end. Okay, so the first matrix is row echelon form. And what are not? Example, the second matrix 2, 3, 4, and so on is not row echelon form because the first entry 2 here is not leading 1. Okay, if it's a non-zero, it must be 1. The leading entries must be 1. Second example, you have this row contain entirely 0, but it is above the second row is not true. The condition 3 is not satisfied. So it is not row echelon form. And the last example, what do I have here? Suppose I have 1 for example, or say 1, 0. And you see this one is not row echelon form because row 1 leading 0 here has more than leading 0 in row K plus 1, right? The condition 2 is not satisfied. So it must be row K must have less leading 0 than row K plus 1. Okay. A matrix is in reduced row echelon form if 2 conditions are satisfied. The first condition is in row echelon form, and second condition is reduced. What does that mean? The first non-zero entry in each row is the only non-zero entry in each column. For example, this matrix is in reduced row echelon form. So its first is row echelon form, leading 1, leading 1, leading 1, leading 0. Here you have 1 leading 0, you have 2 leading 0, and the last one, if they are entirely 0, it must be at the end. And it is reduced because here you have leading 1, then only the rest in the column must be 0. This is leading 1, so the rest, everything in this column is 0. Everything in this column is 0. Okay. Second example. Okay. Second example, this is reduced row echelon form, so it must be a row echelon form. So leading 1, leading 1. Number of leading 0 are 3, number of leading 0 are 5. Okay. And on the entirely 0 here must be at the end. Okay, now it's reduced. It's reduced because, okay, now I have leading 1, right? So the rest in the column must be 0. Leading 1, the rest in the column is 0. So we are done. And for question 1, let's do the first example A. Is it row echelon form? So leading 1, good. Leading 1, good. Number leading 0, good. And there's no row with entirely 0. Okay, so this is row echelon form. Is this reduced? No, it's not. Reason is this is leading 1, so the rest must be 0, but instead it had 3 here, so it is not reduced row echelon form. The rest should be similar.